Today we talk about the statistics final review. Final review for chapter 6, 7, 8. Important formulas for chapter 6. Z-score or standard score. Z equal X minus population mean over standard deviation. Z value for the central limit theorem. Z equal sample mean X bar minus population mean over standard deviation divided by square root of n. N is the sample size. Mean and the standard deviation for binomial distribution. Mean equal n times p. P is a probability. Standard deviation is the square root of npq. First question. The average weight of adult male bison in a particular federal wildlife preserve is 1,460 pounds. So given population mean is 1,460 pounds with a standard deviation 260 pounds. So given sigma standard deviation equal 260 pounds. And find the weight of an adult bull whose z-score is -2. Z equal -2. And find out the x. So use the z-score formula. Z equal X minus mean over standard deviation. So the Z equal X minus mean over standard deviation. Then you do times sigma both sides. Get Z sigma equal X minus mean. Add mean both sides. So you got X equal mean plus Z times standard deviation, sigma. So X equal mean is 1,460, plug in mean, mu, plus z-score equal -2, plug in z. Standard deviation 260, put in sigma, and got this. So got 1,460 minus 2 times 260 is 520. So get 940 pounds. So the weight of an adult bull whose z-score is -2, the weight is 940 pounds. So circle C. Second question, for a normal distribution, normal curve, this is a normal curve with a mean is 10. So mean equal 10. So given mean equal 10. And the standard deviation is 2. So sigma equal 2. Standard deviation is 2. Which of the following range of the variable is the x, this is x variable, range of the variable x, which is this x, will define an area. Area is the under the curve, the area under the curve, corresponding to a probability of approximately 47.5%. So this we call empirical rule. Empirical rule also called 68, 95, 99.7 rule. 68 is one standard deviation above the mean. Like a mean equal 10. One standard deviation is 2. So add 2 is 12. Minus 2 is 8. So the x between 8 to 12, the probability is 68% from 8 to 12. When variable x from 6 to 14, 14 is 12, add another 2, get 14 is 2 standard deviation away from mean. And 10 minus 4, get 6. That is 2 standard deviation, minus 2, get 6 from 10. So it's 2 standard deviation about the mean. So the variable from x to 14, it is probability is 95%. 95%. 3 standard deviation from 14 add 2 get 16, and from 6 minus 2 get 4. So from 4 to 16, the probability is 99.7%. Now question asks you 47.5%. 47.5% you times by 2. 47.5 times by 2 is 95%. Is 95%. So 95% you divided by 2 is 47.5%. So it's 95% from 6 to 14. So divided by 2. So from 6 to 10 is 47.5%. From 10 to 14, also 47.5%. Now you look at here, from 6 to 10. So here from 6 to 10 is 47.5%, is 2 standard deviation below the mean. So answer is from 6 to 10. From 8 to 10. From 8 to 10 is 34%. Is 68% divided by 2. Is 1 standard deviation below the mean. That's 34%. From 9 to 11. 9 is here, and 11 here, and 9 to 11 this area, and that's we don't know. From 7 to 9, 7 here and to 9 here, that's this area, that's also we don't know. So answer is D. Empirical rule. Question 3. If a normal distributed group of test score have a mean, so given mean is 60, mean is 60, and a standard deviation is 10. So population sigma equal 10. And find the percentage of the scores that will fall between 45 to 70. So looking for x from greater than 45 and less than 70. So use the z. First of all, convert x to z score. Z, if x1, first x1 is 45, x2 is 70. So z1 equal x1 minus mean over standard deviation. So the 45 minus mean is 60 over standard deviation is 10. So it's 10. So then 45 minus 60 is negative 15 over 10 is negative 1.5. And the x2 is 70. So x2 is 70 minus mean 60 over 10. So 70 minus 60 is 10 over 10 is 1. So z2 is 1. That's means 1 standard deviation above mean. Then probability from x go from 45 to between 45 and 70. That is equal probability of z score between negative 1.5 to 1. So it is equal to, because this normal curve, and this is x, this is the mean, equal 60. And then you go one standard deviation, it's 50. And 2 standard deviation, because standard deviation is 10, so you minus 10 got 50, minus 10 got 40. Now here is a 45. 45. That is a 1.5 standard deviation, half of it. So corresponding z score. Corresponding z score, z1. And this is x1. Z1 is negative 1.5, 1.1 and a half standard deviation below the mean. Another side is at 60. 60 is the mean. Add 10 is 70. So that's x2. Then x2 you convert to z score. Z2 equal 1. That's one standard deviation above the mean. And question asks you this area. So since on our we are using the table standard, which is Z table, standard normal probability, which is Z table. And here, this body entry is a probability to the table entry, which is this, is to the left, this area of Z-score. So the table entry for Z is the area under the standard normal curve to the left of Z. This is a standard normal curve, and this is to the left of it. And this also, the other side, is also left of it. So we need to convert this equal probability of Z less than 1, which is this area to the left. We can figure out by the table. We can figure out probability of Z less than 1 minus probability of Z less than negative 1.5. So this one. Then we'll get between. We are looking for this less than 1 is from here up to here. That's area. Minus probability of Z less than negative 1.5, which is this area. And that's get the area between. So we look at the table. First of all, Z less than 1. 1 is 1.00. 1 equal, this 1 is equal 1.00. 1.00. And this equal negative 1.50. So first of all, 1.00. Look at the table. 1.00 1.00, which is 0.8413. So this probability is 0.8413 minus this probability, this area. This area is to the left of negative 1.5. Which is the probability of Z less than negative 1.50. So when you look at the table, negative 1, negative 1.5 here, negative 1.50, which is a 0.0668. The area is a 0.0668 is this area. And this entire area and minus this area, minus is going to be between area between 45 and 70 under the curve. The probability is 0.7745, which is 77.45%. Then next question, B. Find the test score for which 20.9% here, 20.9% of the area under the normal distribution curve lies to the right of it. Find this test score, find out X. So first of all, we need to figure out the Z-score to the right of this Z-score. To the right of Z-score, the area is 20.9%. 20.9% change to decimals, move decimal point to the left 2 position, got 0.209. and subtract from 1 and get 0.791 is equal 0.7910, which is this area. Because on the table, they give you this area and find the z-score. So you look at the table, 0.791 is the area to the left of z-score. Is 0.7910 here. 0.7910. 0.7910 is this number, and z equal 0.81. 0.81. So then z equals 0.81. So to the left is 0.7910 probability. The corresponding z-score is 0.81. So to the right is 20.9%. The z-score also 0.81. So then you got the z-score is this. Then you use x equal mean plus z times sigma. So mean is 60. Standard deviation is 10. Plug it in. So mean is 60 plus z-score is 0.81 times standard deviation is 10. So it's 60 add 8.1, get 68.1. So this score is this z. It's 0.81%. 0.81 standard deviation above the mean, corresponding x score. Corresponding x score is equal to 68.1. The score is there are 20.9% of the score is above the score, 68.1. And the question 4, find two z values so that 34% of the middle area. So middle area, this is the mean. Mean is here. And this middle area is 34%, is 0.34. Is bounded by them. And find the two z scores. So this is 0.34. So you do total, it's 1 minus 0.34. You got 0.66. 0.66 divided by 2, and you got 0.33. So that's the two sides. Is 0.33. Left side is 0.33. Right side is 0.33. Since on the table is to the left of z-score, so we can figure out 0.33 to the left, what's z-score will be. So you look at the table, 0.33 is here, 0.333, 0.33 here. 0.3300 is the same as 0.33. You can drop this to 0. So that z-score is a negative 0.40. From here, from this, you go top is 4. So you got is negative 0.44. 44. So as a corresponding z-score, this side is a negative 0.44. And since it's symmetric, the other side is a positive 0.44. You can check it. This area is 0.33 and this area is 0.34. And to the left, add together, 0.33 at 0.34 is 0.67. And 0.67 you got it's 0.67 here. 0.6700 is equal 0.67. And the z-score is 0.44 positive. So this side is a positive 0.44. The other left side is negative 0.44. So the 2z score is a positive negative 0.44. Question 5. The average number means mean of mosquitoes in a stagnant pond is 65 per square meter with, so the mean is 65. There's a per square meter has 65 mosquitoes in the pond. And with standard deviation, sigma equals 6 mosquitoes per square meter. If there are 25 square meters, so n equal 25 square meters are chosen at random for a mosquito count. Find the probability that the average of those count is more than. So the average x bar. So the x bar is more than, greater than 65.9. So is the x bar sample mean of those 25. Sample mean is greater than 65.9 mosquitoes per square meters. And assume that variable is normally distributed. So you will figure out this is sigma given, population standard given, so use z-score equal sample mean minus population mean over sigma over square root of n. Sample mean is 65.9 minus population mean 65 over standard deviation is 6 over square root of n. N is 25. So here 65.9 minus 65 is 0.9 over 6 over 5. 25 square root is 5. Reciprocal, so the 6 on denominator, 5 go numerator. And you got tying together and got 4.5 over 6 divided is 0.75. So looking for greater than, more than. So looking for probability of x more than, greater than 65.9. That is equal probability of when 65.9 corresponding z-score is 0.75. So the equal probability of z greater than 0.75. And since greater than, so you are looking for this, then z-score is 0.75. You are looking for greater than, looking this side. And since on the table, they will give you this side. So its total is 1. And total probability on the curve is 1 minus probability of z less than 0.75. You on the table you can find this probability, and you do total 1 minus this area, you will get the answer. So it says 1 minus probability of z less than 0.75. So you look at the table, z table, 0.75, 0.75 here. So it's a 0.7734. So that's area is this area is 0.7734. And 1 minus 0.7734, you got this area, this area. That's more than 22.66%. And the question 6. The average hourly wage of worker at a fast food restaurant is $9.50. So the mean given is 9.50. And you can drop this 0 equal 9.5 per hour. Assume the wages are normally distributed with standard deviation is $0.50. So the sigma equals 0.50, which is the same as 0.5. If a worker at this fast food restaurant is selected at random, a worker. If a equal n equal 1, a worker. What is the probability that the worker earn more than $10.25? So looking for x greater than 10.25 probability. So first we'll convert 10.25 to z-score. Z equal x minus mean over standard deviation because only a worker. You can divide it by n equal 1, then divided by 1 is still sigma. Then 10.25 is x minus mean is 9.5 over standard deviation 0.5, plug in. Then 10.25 minus 9.5 is 0.75 divided by 0.5, got 1.50. So looking for probability of x greater than 10.25. 10.25, you got z scores 1.50. So it's equal probability of z greater than 1.50. So it's looking for the probability when z is greater than 1.50. And since the table only gives you this area, so total probability under the curve is 1. 1 minus probability of this, z less than 1.50. So you can find out this probability by the table. So by the table 1.50, it's here 1.50. That 1.50 is 0.9332. 0.9332. So is this area 0.9332. Then you go total it's 1. You minus 0.9332. Then you will get this area. So this answer is for this area to the more than 10.25 dollars. So for question 5, n equal 25. You divide by square root of n is 25. For question 6, n equal 1, because here say a worker. And this has 25 square meters. So it's divided by square root of n is divided by square root of 1. Is still 0.5. That's the difference. Then question 7. A baseball player's batting average is 0.360. So this is we call the probability of getting a hit each time at bat is 0.36%. The batting is average is 36%, which is a proportion. We call proportion. Probability P equals 0.360. A probability P. And if the player played 250 times, so n equal 250 times. That's the given condition. Find the mean and standard deviation for the baseball players getting a hit each time at bat. So this is a binomial distribution because a player either get hit or lose. There's only two. Each time only two outcomes, either getting a hit each time at bat, or just lose. So it's a two P equals 0. Probability get hit is 0.36. Q is do not get hit. Is Q. Q is 1 minus. Q is 1 minus P, which is 1 minus 0.36 is 0.64. So this is a binomial distribution. Binomial distribution for the mean and the standard deviation, it's for the binomial binomial distribution, mean equal n times p. Standard deviation is square root of npq. So n times p, it's mean equal n times p. N is 250. Probability is 0.36, so you got 90. 90 hits. 90 hits. And the standard deviation is the square root of npq. N is 250. And p is 0.36. Q is 1 minus 0.36 is 0.64. So you figure out this, 250 times 0.36 times 0.64. Use calculator. You got is the square root of 57.6. And use calculator, take square root of 57.6. You got 7.5895. That's the standard deviation. Now this binomial distribution, you can use normal distribution, normal approximation to the binomial distribution, and correction for continuity. So B. Instead of using binomial distribution, you can use the normal distribution to approximate the binomial distribution, but you need to correct for the continuities. What is correct for continuities? Find the probability that the player will have a bad season and get at most is the maximum one. It's 80. So it's less than or equal 80. So we want is x less than or equal 80 hits in n is 250 times. So at most, which is the maximum one, is 80. You will not over 80, not more than 80. So you want to figure out probability of x less than or equal 80. So for the continuity, in order to cover this 80, because here want equal 80, x equal 80. If this is 80, in order to cover this 80, so you have to move up a little bit, 80.5, a little bit, find this area. That is the x. That will guarantee cover 80. If you don't, because the probability we only for less than or greater than, we don't, for the table, it's only for less than or greater than, doesn't have equal. So like here, want to be x less than or equal 80 in order can cover equal 80. So you have to move up a little bit, get 80.5. Then to find out this area, find out probability of x less than 80.5. And this probability will cover probability of equal 80. So you cannot just use 80, because you use 80, use that table, they were not including 80. Or not including 80, because the table only do is the probability of x less than the number. Doesn't have a x less than or equal the number. In order including 80, you have to move this number up a little bit, 0.5. So it's 80.5. Then for continuity, become probability of x less than 80.5. That is guarantee cover equal 80 probability. So for the continuity, you have to use x equal 80.5. And then figure out the z-score. The z equal x is 80.5 minus mean. Mean, we figure out here, it's a 90 over standard deviation is square root of 57.6. And then 80.5 minus 90 is a negative 9.5 divided by square root of 57.6. And use calculator, you can find out it's a negative 1.25. So this x, it's 80.5. Corresponding z-score is a negative 1.25. So then probability of x less than or equal 80 for continuity. Correction become probability of x, figure out probability of x less than 80.5. 80.5 convert to z-score. So the z, probability of z less than negative 1.25. Less than negative 1.5. And use the table. Negative 1. Negative 1.25. Negative 1.25. 5 is this. Intersection. This. Negative 1.25. This. Negative is 0.1056. 0.1056 is this area. This is the answer. Then question 8. Of the members of a Boy Scout troop, 20%, P equal 0.2. 0.20 is 0.2 equal. So P equals 0.2. Have received the first aid merit badge. If 50 Boy Scouts, so N equals 50, are selected at random, and find the mean and the standard deviation for the number of Boy Scouts who received the first aid merit badge. So figure out mean. Mean is N times P for binomial distribution. 20%, this is a binomial distribution, is because each trial have 2 outcomes, either have received the first aid merit badge or do not receive. So 20% receive, so 80% is not Q. Q is 1 minus P, which is 1 minus 0.2, which is 0.8. That's 80% not received the badge. So it's binomial distribution. You can find the mean by the formula. It's mean equal N times P. N it's 50. P is 0.2. You got 10. 10 Boy Scouts. Out of 50 Boy Scouts, 20% receive badge, merit badge. So 50 times 20%, you got 10 Boy Scouts receive the badge. And the standard deviation is square root of NPQ. N is 50, P is 0.2, Q is 1 minus 0.2, which is 0.8. So tying together is 50 times 0.2 times 0.8 is 8. Take square root is 2 square root of 2. And use calculator, you can figure out is 2.8284 boys. Is the standard deviation. B. Use the normal approximation to the binomial distribution and the correction for continuity. Find the probability that 6 or more. So figure out probability equals 6 or more than 6. So it's x, looking for x greater than or equal 6. Will have the first aid merit badge. So we are going to use the normal distribution to approximate binomial distribution. We have to correct for continuities. Now this is a 6. Probability of x greater than or equal 6. If you just use 6, use the table, you will not get equal 6 probability included. The table only for greater than, doesn't, or less than, do not for greater than or equal. So in order to guarantee to get equal 6, so this one, this, if here is a 6, you want the probability greater than or equal 6. If you just use table with 6, you will get probability not including equal 6. So in order to get, you have to go lower a little bit. It's a 5.5. And then you find out this probability, that's what guarantee equals 6. So you have to change x, use greater than 5.5. So for continuity, you find the probability of x greater than 5.5. 5.5 corresponding z-score. So x is 5.5 minus mean. Mean figure out on is 10, minus 10. Over standard deviation is 2 square root of 2. So the 5.5 minus 10 is negative 4.5 over 2 over square root of 2 times square root of 2. Use calculator, you can figure out it's negative 1.59. So this z-score is negative 1.59. Negative 1.59. Then you are looking for greater than. I should, because it's negative, I should draw on negative side. So it's on the left side. Right side is positive. Left side, the left side is negative. So is this, I should draw over here. They're looking for greater than or equal 6. Looking for this area, but including 6. But if you use 6, find z-score, then you will get is greater than 6. You want, because table only for greater than, doesn't for greater than or equal. In order to guarantee including 6, so you have lower a little bit, 5.5, and find this area, that's including 6. So z-score here, it's figure out it's a negative 1.59. So is greater than 5.5 is the same as z-score greater than negative 1.59. That will guarantee have probability when x equals 6. So greater than, a table only give you this area. When you have to do 1 minus this area, you will get it. Greater than area. So it's the same as 1 minus probability of z less than negative 1.59. This corresponding to negative 1.59. So 1 minus z less than negative 1.59, and you will use the table, negative 1.59, negative 1.5. Here, negative 1.5. 9 is here. So negative 1.59. The area is 0.0559. So this area is 0.0559. That's this area. Under the curve, total is 1. You minus this 0.0559, and you will get to the greater than this side. So this side, it's a 94.41%. Have more than 6 or more than 6. Have the first 8 merit badge. That's for chapter 6 review. Chapter 7 review.